Okay, I've got some sound. I'll get started here. And one of the things I'm going to do is go over to a place called Vital Source. They have our textbook online, and I like this. I could tell you I know it's a change to go from a cloth textbook or a physical one to a digital. But I've been using Vital Source, as you can see in this course, because I have it part of my bookshelf. And I really like it to be able to show you the text passages right there. I wish I could get all of my texts on there like that. I'm going to click on my bookshelf here for a minute. I'll find the book. And here we are. Okay. And let's see. I want to go down to the table of contents. I'll tell you what, I'm going to search for Hammond's Port 1. Now let's see what I find. Well, Hammond's Port 1 is on pages 561 to 72 of your textbook. And that's chapter, I think it's chapter 11. Oh, it's chapter 12. Okay, chapter 12. So I'll just go on over to chapter 12. Down here. This is on simulation. Now, and then we'll look at I'll find the Hammond's Port 1 starts at page 561 and goes over to page 572. So it's the bulk of that chapter. And what we're going to be doing is simulating waiting lines. Now, you know, we did the single arbitrary last week, and I'll talk about it a little bit. And that's queuing theory or waiting line theory, okay? And of course, we can gather some ex post facto data as we can gather some data after the fact and make adjustments and or try to see what we can do. And that's why we did the simulation. We used the simplex, but we can also, a more powerful way to do it rather than actually trying it is to build it by simulation. And this has become, in any way that we design products, that we design services, the digital processes have come into play. Computer-aided design is the first step, and then computer-aided manufacturing. But computer-aided design works beautifully for products. It also works beautifully for services or queuing theory kinds of problems. So when we look at Hammond's Port 1, we're going to look at using simulation to try to build a model, if you will, of this waiting line or potential queuing operating characteristic. Now, just as you've probably heard me share this before, but I can't emphasize it to you enough. The two most powerful tools in Excel, okay, is the pivot table, which allows us to kind of get the best of the both worlds of the database and the spreadsheet. And then I think the other one are the randomization functions, ran between, random. Those let you build simulations. Now, you know, we all know, and we're all pretty familiar with how CAD, the computer-aided design, can do fantastic things. And now, of course, you not only use that for the design, but now we have the ability to graphically fill those out. So, you know, you can see the airplane on a desktop or whatever product's being designed. Okay, you could design there's some really, really powerful, highly expensive tools out there where you can simulate, you know, create a virtual reality, if you will. Okay. And so simulation, though, is the bottom, is the is the start of all of that. So we're going to, this Hammond's Port 1 will be an interesting, because we're going to simulate the data. In other words, we're going to see what are the possible outcomes. Now, from our actions, not afterwards, but we're going to try to simulate to try to figure out and optimize our waiting periods and get them obviously as low as possible. And I've got some links over there for you that talk about how long customers will wait, how queuing theory, if it's not handled well, or waiting line can really hurt us. And this is not only in the delivery of goods and logistical things, but you take a restaurant, for example. There are some restaurants that don't serve people as fast as possible, and they lose business. Now they may be and typically it's not because because they're too slow. It's typically because their waiting is too fast. And a fast food restaurant really is nothing more than a turnstile with a meal, and that's really all it is. So waiting line and simulating these are a good way. And we can also, for example, in disaster situations, we can simulate how long it's going to take us to get one wave of stuff that people need at day 1, day 2, day 3, etc. And so this is kind of a baby model of that. All right. Now, simulation is based upon the whole idea, all right, that I take it, and this is again where we're going management science. I find a model that works out in the world, okay, and then I try to build it. And if I can do all then I'll try to build maybe an iconic model like a flow chart. Then I'll try to build a mathematical model, okay? And for a minimization is typically what we do with waiting line problems. We don't want to maximize, we want to minimize them. However, let me say this: if you go to a lot of restaurants, they may ask you if they have a separate bar. Would you like to go in the bar and wait till you're called? This is to sell you something while you're waiting. And so the simulation is a powerful tool. And I can tell you, having worked in cash flow analysis as a consultant for quite a while, and it's been a long time since I did, but when we got spreadsheets, it used to, when I first started working for those folks, I was doing it on a consulting basis, okay? I was with a team of people, and it would take us, 2 months, 3 months to build between 5 and 10 scenarios. And these were typically merger and acquisition kinds of situations or new product development rollouts. And like I said, to get 5 to 10 simulations, it was several months. When I left it, and Excel, we were using the tools in Excel, we could run thousands of simulations within a month. And of course, the law of large numbers takes over. The more sampling you do, the greater the chances that you will get a tenable figure or number. Of course, as we've talked about in this course, you've heard me in other courses, decision making is not binary. It's continuous. In other words, I can make a decision that's kind of in the middle, not too bad, not too good. I can make really bad decisions or really good ones. And so you have to be a good manager, you have to abandon this idea that this is the answer or that is the answer. Typically, if you do, here's what has happened. You'll be victim of the law of unintended consequences, or you'll become a victim of the law or the myth of equifinality, the notion that I can take the same set of resources, okay, and produce the same outcome. And when we did the data envelopment analysis, you remember those hospitals, and we built the composite hospitals. And then we looked at, okay, well, does hospital A meet the composite? Now the text may have I don't agree with the authors in one thing. When you do a DEA, all right, you've got to be thinking about standard deviations, variability, and so you want to say, okay, if it's within half a standard deviation above or below, then I have good operating discipline, or I have good Q discipline. If not, I have a problem. So you're going to find it's going to be fairly interesting, and one of these tools that helps us build predictive models. Okay, business has been pretty good at telling us, like, annual reports. What happened? Okay. Now we're trying to catch up with what is happening, and with all the data that's out there and all the sensors and mobile computing and all that. That's a challenge. The ultimate challenge for us is prediction. That is being able to predict with some precision, okay, how something will work out, okay? And that goes from building profiles of customers or profiles of product characteristics, whatever, to say, okay, here's where I think it might fall. Here's the range of possible outcomes we're going to get. All right. And when we're thinking like that, and when we're operating like that, we're far better off. So this is going to be a good case. Now, the other thing we've got on our plate, okay, is outliers. And this is from chapter 9 of the Data Smart text. All right. And we're going to look at that. Okay. And it's over on page 335. And this is a case on outlier. And what this is this is a case where we're going to look at the performance, okay, of some people who work in a support center. And we're going to apply some dimensions or variables, and we're going to go through a process of finding out the folks who are outliers. And we'll do some things with some of these functions in Excel, like the offset function. We'll standardize the numbers, okay? And we're gonna revisit some of the stuff we looked at in cluster analysis, but this time we're not looking for how people or how data points cluster together. This time we're looking for stuff that's off the charts, off the norm, okay? For the longest time, when I review, and I still do it, I review for a couple of journals. I'm on the editorial board for them. And so I look at original research. For the longest time, a major complaint of mine with authors was they would not report their outliers. Okay, they provide data that was all smoothed out and nicely, and so basically what they did was anything that was a far outlier, they eliminated it from the analysis. My question always was it one outlier, 5, 10, how many? And the other is my belief, but also I felt like what you were doing was you were reporting data that had been impacted by that outlier, but you didn't see the outlier. So you really weren't dealing with a clear picture. Now there are some now today you see it more and more where people will say, okay, here's some outliers that we found, or an outlier. Okay, and then you're able, if you really truly want to take their summarized data, like maybe they ran a multiple regression, whatever, and see how that was impacted, okay, and how it's changed, and particularly how it changed the picture of the distribution. And you remember, when we talked about the quartet, where we took four sets of data that had the exact mean, all of the exact central measures of central tendency and the variability, and then we charted them. They looked completely different. Okay, and so we have to be thinking about that. So that case is chapter 9, page 335, the outliers, and you're going to find it will be useful. And I think it's a good case for you, not only because we do some more kinds of work with doing some analytics, but more importantly, I think it's good to help you because at some point you're going to be asked to evaluate a person. Okay, and I throw in the DEA, the data development analysis, that hospital, because it's a high probability that at some point you'll be asked to judge a unit's performance, store number 11, or County Hospital, or or State Farm Agency 953. Yeah, who knows? And so I hope you will at least harken back to this. And if you're really smart, you'll go back and go, what do we know about data development analysis? And what can I find? And how could we use it? In this case, we're going to look at outliers. Okay, and we may also want to do this not as only as a negative thing, all right, but as a positive thing. We would find the high performers. Why are they performing at a high level? Okay, so it's going to be, we're going to have those things going on. Well, I've got the book up here, okay, and from Vital Books. And again, like I said, I really enjoyed having them here for us to see. Now I'm going to take us over here to, and we can go to, see, 563, and that's jumping ahead a little bit. That's waiting line simulation. And that'll put us in those, that'll put us back here. Okay. And you can see they had the Butler inventory simulation, and then and then we'll move on over. And I said to myself, okay, probably not a bad idea for you to kind of start over at 561. Okay, and then read on over to page 572. Okay, and let me pop us down here. And they build us the model for customer arrival time, simulating that. Okay. Now, the book has a couple of appendices, and I would really encourage you to take a look at them. Simulation with Excel. Now, they also introduce you to another somewhat popular product out there, Crystal Ball. I'm convinced that unless you're dealing with hundreds of thousands of pieces of data, okay, and you need the answer to, and you need the data crunched fast, you probably don't want to use Excel. But for most purposes, you're going to want to use it, okay, or you can use it. Let's put it like that. Let me go back over here into the modules area, and you can see what we've got going on. And of course, this is the pre-record for Monday the 9th, okay? And then on the 11th, I'll do a live screencast. So one of the first things we want to do is we want to take a look at single arbitrary. Now, I want you to, and I'm going to go ahead and make the key published. I'm going to publish that key, so it will be there for people to see. And then I'm going to discuss it. All right. Now, I have a link there for you which is a recording just on single arbitrary. If it will do you any good, I would encourage you to take a look there. Now, look, I know that all I say, if you'll just try them, you'll just upload these. These are workshop credits, okay? And I want you to learn and understand and have a comfort. I want you to feel comfortable trying several times to see what you get, and then I'll walk you through the process. Okay, and there's nothing here that you'll notice what I'm having you do is insert data, okay, into pre-existing models, and then play with it and see what you get. The reason is because it takes you a while to get comfortable going through the whole process of, you know, yeah, is this, what type of problem is this? Is it maximization, minimization? Do I have a target level? Then what type of data am I dealing with? Linear, or am I looking at non-linear data? That kind of thing. What are the decision variables and all that? And typically what we're seeing here, okay, in this textbook, firms that actually use this typically have a committee or a team that put this together. All right, and they may have just simply give you the model and say change the variables. All right, the whole idea being that, you know, the model building process is important. It's critical, because if you don't get the right decision variables, if you don't know what you want to do, you're gonna get garbage out. So that's why it's a tool that's really powerful. It's easy to use, okay, but it takes some, or you may be fed those data from other departments, who knows, okay. The main thing is not just being able to operate this, because look, you can go to YouTube and they cover how to do all of these techniques every which way but loose. The main thing is to get your mind thinking like a successful manager, or thinking like how successful companies do. And that is understanding, when I make a decision, I always need to be thinking about the range of possible outcomes, okay? And I always need to be thinking about the fact it's not binary, and also need to be thinking about what are the unintended consequences, good or bad, of my action or my actions, okay? Well, let's look at single arbitrary for just a minute, okay? And I have the key up there for you to see, and we'll spend a little time on it today. Like I said, there's also a link, and then we're going to start on that case, the outliers case over there from Data Smart. Now, I won't go on. I'll spend some time today. The bulk of this on Wednesday will be on that outliers case, and that will live stream, okay? So let's open up the single arbitrary key, and we'll download it. All right, let me pop this back here for a minute. I hit the wrong, it's down here. All right. It's going to pop up here, and we're going to download it and take a look at it. And you'll want to download it to your desktop, okay? And then I would open it. I would load it to the desktop of your device, then rename it, okay? So you can have it to upload. Now, I want to say something. I just got through grading today, and what befuddles me is how I can have these workshop credits, okay? And I can say, okay, all you have to do is try it. If you don't, I don't nitpick through it. Now, I will on the exams, as you know, check to see if you've really been listening, pay attention, because I'll give you a hands-on where you'll have to use some of this stuff. Okay, so I'm not just giving away credit. You're as you work through your hands-on part of the exam, if you haven't participated and you haven't looked at these and tried them, you're going to be as lost as a goose in a rainstorm, okay? But it's beyond my comprehension how that I have some folks that aren't uploading work. I don't get that, okay? And you're losing credit. I'm sorry, I'm a little incredulous, but sometimes often it's the same people who come back to me and go, gee, my grade's on the bubble and this and that. Let me give you a piece of news. Okay, as we come down to that point where we start, a lot of you start to get religion about how well you're doing in the course. Please understand, if you're on the bubble between a B and an A, I'm going to go in, and what do you think I'll do? Let me give you a choice. One, I'll toss a coin, or two, I'll draw straws, or 3, I'll go into the analytics package of Canvas and see how much you have participated. Okay? This ought to kind of put a little bit of fear in you for a simple reason. Canvas monitors your activities, and it has a baseline, say 100%, which is like an IQ score of 100, which is a common. Okay, and if you're below that and below significantly, I know you're not participating because the software tells me so. It tracks what you're doing and what you're not doing. Okay, if you're really participating and trying and working, and that doesn't even mean you attain the screencast. That means I know how many pages you look at. I know when you upload work or don't. I know when you download stuff or you don't. If you're below, I'm not going to feel real good about bumping your grade up for the simple reason that I didn't see you trying. And with this course set up like it is, and you know how some of you have said, boy, you're kind of rigid on late work. Yes, I am. The way this course is structured, come on, you can work on it any day, time of night, and you can work on it remote. You can work on it in the lab. So, I'm saying this for a simple reason, not just because I want to aggravate you, which probably some of you have had, but here's the thing. If you have this habit of not turning in work, not making commitments, then this is a habit, and it's not a good one, and it will not do well for you when you go to work. I don't care how good you are, how smart you are, how nice looking you are, how well you interview. I don't care if you're in all the social clubs and organizations at school and all this. If an employer hires you and you don't show up, or if you don't get your work completed, trust me, it will not go well for you. Okay? And so when I give you these opportunities to earn some credit, because I know the exams can be pretty difficult, take advantage of them, okay? So end of sermon. Okay, let me go on and click on enable the editing on this jewel, and I'm going to take it and I'm going to save it on my desktop on my device. And the reason I'm doing this is so I don't create a phantom file that is a system file that's really nothing more than a view, okay, and that later you can't upload. I've had a couple of people upload corrupted files, okay, and I don't get that. I think probably what's happened is you haven't followed the procedure, or maybe you're working on some old software. I just don't know. Okay, now you can see I've done this a few times. It's single arbitrary 6. So I'm going to put single arbitrary key. I'm going to put Harmon, Keith. Okay, and I'll save it to the desktop. All right, and it's down there. Now I will even go ahead and I'm going to close this off for a minute, and then I'm going to diminish my browser and go back down there and see if I can find it. And and there it is. Okay. Now, go back over here to the modules for a second. I want to talk about some housekeeping before we go too much further with this. All right. Okay. This week you've got 2 things that you have to turn in. All right. You have the support center, yeah, that's going to be the support center, the outliers problem, and then Hammond's port 1, okay, and then you have the Chapter 11 exam. Now I have some resources for you here, like for example ROI on analytics, okay, and how when we do all this work with analytics and all this stuff, I can tell you right now that we have good data that indicates that if you use these tools, okay, it disciplines the organization so that the organization operates like it ought to, because it's operating on fact, not somebody's whim or somebody's insights they got after they had too many drinks at the bar, or too many cups of coffee, or whatever. There's an old saying, data tortured sufficiently will tell you anything. Okay. And so you want to, if you're doing this well, you're not torturing the data. Okay. Now, so you have the support center XLS. That's this outliers case. That's from the data smart. That's due. Chapter 11 exam. That's due. Okay. And then I have those resources here for you. Okay. I even have some, when we look at the support center case, I've even got a little calculator that lets us analyze or determine, if I get a particular Z-score, what is the probability I would get that? And as I said, we're always looking at that continuum decisions. Now that's, and then I have some very, very practical why we won't wait customer satisfaction and points and profits by decreasing wait time. And longer people wait to eat with you. If you go to, I can tell you, if you're like me, there are probably some restaurants you avoid because you'll sit there and wait forever. Now those restaurants, I don't drive over to them and say, hey, go tell the manager, hey, because you don't handle your queue well enough and get people shoved through here, I don't eat with you. Because that manager probably go, thank you for your information, and go on back to their work because they got a full house. But here's what might happen. If there's 1,000 of me, they might need to expand that operation or open another store, but they'll never know, will they? Okay, so there you go. Here's an article on how long will customers wait for service. Again, people want stuff overnight. They want it now. That's the world you live in. Okay. Now we're going to go down here to module 11 because we're in module 10 this week. And you can hear, we'll go back over Hammond's port. And then you have Hammond's port 2. Here's another version of it. Then you have chapter 12 is due. Okay. And so those are the two items that you have due. Now I want you to notice something. I have given you a really tremendous set of resources here about queuing theory and Little's law, that's a key piece of queuing theory, and applied that to these analyses. And here's some cases of reducing the work in progress of a frozen food manufacturer. Here's a resource about Starbucks. So there's one in a manufacturing setting, there's one in a retail setting. Here is information about the Poisson distribution, which is the scientific basis for waiting line. As you've heard me say over and over, management science, we try to find a model out in the real world that mimics or looks like what we're dealing with. And the Poisson, that S curve, is one that fits with waiting time. That's why we call this management science, okay? And as you can tell, it's not as esoteric as people want to make it. It's a lot of it just common sense. Then we have, some resources on Excel's normal distribution functions. Okay, we're always trying to figure out, are the data normally distributed or not? Okay, that's the most important question any researcher always has to confront before they start writing. They do research. If they're normally distributed, then that makes sense that we would use those tools. If they're not, then we've got another kind of critter that we're holding. Now, you probably see in the news or hear if you've had your finance where people talk about, the bank bailouts and the bubbles and the financial crises and all of that. Most of the time, those things happen because someone somewhere had a model in their head that doesn't work. For example, believing that property values will always go up is what killed a lot of people in the housing bubble, because they were put into a home they couldn't afford. And then the real estate agent and the mortgage broker said, don't worry about it. In 3 or 4 years or 5 years, when your note your adjustable note comes back due, your house will be worth $40,000 more. So we'll just refi and you'll be good. Famous last words, because housing values don't operate like that. They have a very precipitous increment, and then the bottom drops out, or they have a significant reduction. Land and real estate is more volatile than any other asset, although you'd think it wouldn't be like that. Famous Oklahoma, and Will Rogers said, when they asked him what's your investment strategy, he said, I buy land because I don't make any more of it. And to a certain extent, he was right. But to give you an idea of how a land and real estate bubble can kill you, Japan had one back in the 1990s, and they still haven't climbed out of that hole. Okay, so I've got you some good information there. And then the Norman inversions, to where I invert that normal curve to see if there's something in there that is going to go bump in my night. So I've got some nice resources for you. Okay, well, we are going to go back now to single arbitrary, and we'll talk about that key. Okay, I want to go over it. Again, as usual, I give you a model and say, okay, put some data in it. And I ask you to use GoalSeek to obtain the service cost per channel. Okay, and I ask you to assume that the weighting cost per unit is $1.16. Okay, so we come back up here and we have the weighting costs. Okay, we assume that is $1.16. All right, and I've got that in there. And I want to attain a total cost per period of $2.99. All right, I'm going to go and I'm going to put that in. All right, and the total cost per unit, I'm going to come over here. All right, and I'm going to click data. I'm going to click solver, and I want to maximize C27. That's the total cost. Pardon me. I want to maximize. Okay, the total cost. I want to minimize the total cost per period. All right, or I can also set a target value of $2.99. All right, and we're not assuming that these are linear data. And I want to change the cell. Let's see, I want to change the weighting cost per unit, and I put in a figure, and I can run it. Now I'm just going to do the GoalSeek here. Okay, so I'm going to come over here. I'm going to click on the what if analysis. I'm going to GoalSeek. I'm going to set cell C27 to 2.99. We really had a target there, so we didn't even need to mess with the solver. But I wanted to see what it looked like in there. We set the cell, that is the total cost per time period, to $2.99 by changing the cell, and that is the weighting cost per unit. And we'll see what we can find out. And there we are. Okay, now I want to show you something before we move on and talk about single arbitrary. All queuing theory problems are a lot like inventory problems, in the sense that if my queue is too fast, okay, if I serve people too fast, then I'm probably going to suffer on some part because they're not getting the service that they may want or need. If I serve them too slow, then I don't get to serve enough people. So in a waiting line theory, and this is, people are kind of like the inventory, okay, or service product moments when they get served or taken care of. All right, so there's the solution, okay, and we could use the goal seek. And again, we have the problem, and we'll walk through this. Here's the arrival rate, the service time, and there's the standard deviation for the service time. Okay, and then we have the probability. And notice all we've got going on here. I want you to look at these cell functions. Okay, notice that we've got the probability. Probabilities always have to add to 1. That's why we have the 1 minus B7 over B88. B8. Okay, we come down here, the same story. And we get the average number of customers in the queue. We in the waiting line. Pardon me. Then we have the average number of customers in the system. Okay, and again, remember we've got the people who are coming into the queue, the people who are being served, and that's the total number of people. Then we want to find out those averages. Then we start to look at average amount of time the customer spends in the waiting line system, and then how much time they spend in the system. So we're talking about how much they spend waiting versus how much time they are in the system. So I could subtract the two of those and tell you that's the time it took to serve them. And then I have the probability that an arriving customer has to wait. And in this situation, that's about 70% of the time they have to wait. If they do, I need a queuing, I need a queue discipline tool, which is a fancy way of saying, I got to do something with these people to make sure they don't turn and walk out the door. That might mean what befuddles me is how restaurants, okay, well, people come in and, they ought to know that people come in waves because they service, they build up their staff, they do around lunch, dinner, and breakfast, lunch, and dinner, and that they would have chairs and enough space to take people who will wait and take care of them. And, the truth is, after about 10 or 11 minutes, when someone's waiting somewhere, they hit kind of a point where they go, I'm out of here, or I've invested so much time by now, I might as well wait it out. And it never ceases to amaze me that you can go into some of these, particularly these restaurants, and they don't really accommodate you. They let you stand out in the cold, or you can sit next to a door that's cold. And that's no way to treat somebody who's come to do business with you. And then you say, please wait. So there's a lot of things that can be done with this. Well, that's it in single arbitrary, and again, kind of a rendition of that key, and helping us understand a little bit more fully about queuing theory. All right, now we're going to start on the outliers problem, a case, and this is from DataSmart, okay? And as I said before, it's chapter 9, okay? And by the way, I'm going to say this one more time. On the Hammondsport cases, which there's one this week and there's one next week, and these are these queuing waiting line theories, the stuff that's there for you to look at are pages 561 to 572 that will talk about how do we build those models, what are the assumptions. Then once you've done that, you're going to be able to go out and look at some of these resources I've got you for next week in terms of Little's Law, etc. Now I have one here that I ought to make you have. If you decide to look at any, here's one that you should. This is the 10 minutes that changed Southwest Airlines' future. I always like to make sure you understand this is just not a bunch of gobbledygook here so I can earn a living, or some stupid stuff an idiotic professor somewhere or some egghead put together. This stuff has great practical importance. You say, what are you talking about? Here, this resource, 10 Minutes to Change Southwest Airline, is an incredible story. The man who founded Southwest Airlines, he had two premises for his business. Number one, I'm going to make the price of a flight equal to or roughly equal to the amount of money it would take somebody to drive there in terms of gas and maybe lodging. Smart. Why? Because if you can get there faster and you need to, you're going to fly. The second thing was, he said flying is an experience. Okay. He had grown up flying in little planes, and then he was an aviation enthusiast. So he saw flight as an experience. And he also was old enough, like I am to a certain extent, or on the end of it, when you flew, it was a glamorous experience. People were dressed up in it. You had nice, and that was when only a certain set of the population could afford to fly. It wasn't like flying today is like riding the bus when I was a kid, or riding a Greyhound bus. Okay, we're all crammed in. It's nasty. All you know the horror stories. He said, I'm going to create an experience. So it was one of the things when they were early on. I guess they still do this. I don't fly that much anymore. Is, the flight attendants, they'll tell a joke, they'll sing, they'll do this, and people get off. I remember the first few years that they were in the heyday, in the 80s and early 90s, and people go, wow, weren't they funny? And away it went. It's because he knew flying is an experience, and he wanted you to have an experience. Well, there was one other thing that they did, okay, that really made them, well, the others, as you've heard me say before, they avoid the hub and spoke routine, where I fly, I'm going to fly from Oklahoma City to Memphis, but you're going to route me through Atlanta. Why? Well, Atlanta's the hub for my airline, or Dallas is the hub for my airline. And we've talked about that in networking, where we have a network where everything feeds into the place, and then it's based on economic order quantity. It's based on making sure I send out full planes from the hub. Okay, well, for all intents and purposes, this 10 minutes tells you about how Southwest Airline shaved 10 minutes off the turnaround time on their flights. Okay, by doing so, they had all of their planes in the air. If your plane is sitting on the tarmac, it's not making you any money. It makes you money only one time, when it's in the air. And so what Southwest Airlines said was, we're going to find a way to take 10 minutes off the time it takes us to get a plane in, okay, the people off, and then we restock it, okay, and clean it, and then we board and they go. Now think about it for a minute. Let's say that you have, I don't know, let's call it 25,000 flights a year, okay? And you save 250,000 minutes, which means you can fly 250,000 more minutes. You have that much more time that your planes are in the air doing what they're supposed to do. And you could break that 250,000 minutes into the number of hours, and you could break that into the number of revenue per hours, and you can see it becomes an issue. It can be the difference between profitability or non-profitability. And here's the thing, it's not, airplanes are not cheap. They're pretty expensive. So if you're Southwest and you can get more flights a year out of a plane, then you defer having to replace it with a bigger model, or the same model just refurbished. Okay, you can get more out of it. Okay, just like if you have a restaurant that you know how to get people shoved through it and still have a decent, nice experience, you're going to make more money. So this is an interesting article for you to take a look at. Okay, so we're going to go over it now. We're going to take a look at that. the outliers question, and that's going to be over in the support center file. Okay, and let's go over there for a minute. This is a pre-recorded session, so we'll go close to 50 minutes, maybe a little bit over. It won't kill you. All right, now I'm going to go into the files section. All right, and I'm going to come down. I'm going to find the Foreman files, and here they are, the Foreman files in the zip file. Now, over on page 34 in the Data Smart text, he also gives you the link, I think he gives you the link to his companion website, and the files are over there. To save you a few clicks, I went and downloaded them and then downloaded them up and put them up here. I bought the books, so I'm in good shape. I haven't stolen them. You're welcome. Okay, we'll go download these. Okay, and I'm going to take the Foreman files. I'm going to diminish my browser. I'm going to throw them out here on the, and we'll say yes, copy and replace. Why not? And I'll do this for all of them. And I'll do it for the next set of conflicts. Okay. So I have those files out there. And let me see the Foreman files. And I'm going to open up and I'm going to go to chapter 9. And we'll open that up. And we'll find the file support center. Now, let me add one little piece here. And I'm going to open this up. Okay. Now I'm going to save it. You notice when I downloaded it, it came out in a white little looking thing. It wasn't the Excel icon. The reason is basically what Canvas does. If you've taken data admin with me, where you've exported files, it exports a file. So that download is actually an export process because Canvas is actually a database. There you go. Now I'm going to save this and my desktop as an Excel file, and I'm going to come here to the desktop. I'm going to put support center, Harmon, Keith, and I'll even put the date, which today is, I don't know what the date is today. Okay, 4/7/18. He said, oh, you're working on a Saturday. I know. I'm sure all of you do too. And Sundays and a lot. All righty. Now, let's talk about the dimensions of this. If you've taken data admin with me, then you know that I always say the heart of the whole thing, as anybody would tell you of any database, is the tables. The tables. That's where the data are that you turn into information by mixing and matching records and extracting data. Well, those dimensions of those things are important, okay? That's what ought to be in there, okay? And you've heard me go through the data validation pieces where don't ask anything that's not required, and if you can if you can do it, make the end user put in as much of the data as possible and have them put it into a format that you want to, which is easier said than done, especially if you're working, say, in a place that has volunteers. May the Lord bless your soul, because you are going to have the patience of Job to live through that. But we're looking at employee. Here we have the employee ID. Well, that makes sense, all right. Here's the average number of tickets a day. These folks are in a support center, and they deal with people who come in, okay? Then we have a customer rating. They get rated. Then we look at how many times did they show up late? How many times did they work the graveyard shift? How many times did they take a weekend shift? How many sick days have they taken? Okay. The percentage of sick days are taken on Friday. Yep. Da, 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 da. You're going to learn when you're out there that Mondays and Fridays are employees' favorite days. Friday's a great day to get sick. Monday's a great day to be sick. And we have stuff to do. Okay. The best thing for a company is rather than have all the overhead of run around trying to figure out people, just give them the time off. Okay. And be generous with it, because it's a lot cheaper to do that than it is to hound them and all that business. And then shift swaps requested. So they said, well, hey, I've got to be with the kids. I got to pick them up, whatever. How many times do they do that? Oh, and they have another key thing here is how many employee development hours do they have? Are people, I missed that one, are people devoting time to their continuing education, their development? And then how many shift swaps offered? Now, with this type of data, for example, and I'm going to scroll down here for a minute. When you start to see some people out here, some of these people who have 4 times, I've seen a lot of 4s. I saw a 6. When someone's asking 6 times, they're offering to swap shifts 6 times. This is a person who apparently has a flexible schedule and is willing to help people out. Okay. Now, as you can imagine, I get a lot of excuses as to why people didn't turn in work. And before I started using Canvas and doing these lectures recorded, I used to get every kind of excuse you can imagine for a person not showing up for class. Now, I know if you show up or not because you show up in the live screencast as a participant. If you don't, then I check and I see who came in and looked at the recording, which I can do. So I know if you're attending, okay? And we talked about this before. This system is designed to be flexible for you as possible. So this person here who is offering to shift swaps, to swap shifts, say that 6 times, okay? You're going to find out that this is a person who's they're a team player. In fact, this whole thing, and you'll read this in the case, is what they're really trying to find is, are these people productive? Are they investing time in themselves, the employee development? And are they just an all-around good team player? Okay? Are they or not? And the way I know is our busiest day is Friday and they're nowhere to be found. Our busiest day is Monday. They're nowhere to be found. Or I needed somebody to help me take to swap shifts, and nobody volunteered. So these folks are about you being productive, that's for sure, and for getting a good customer service rating, that's for sure, and attendance. Okay. But you're also looking at these data over here, the shift swaps requested versus offered, okay, and the graveyard shifts that they've taken. This tells you, am I working? How good of a team member are they? And that's what's implied here, okay, and pretty typical. It's a support center, and they want people to call in, okay, and customer ratings, etc. Okay, and as you're just like me, there is nothing that will make you blow a fuse than have a service that you pay money for, a lot of money, and you can't get somebody on the phone to help you. Okay. I'm going to say this. I use Cox cable. I use Cox for my internet. I use Cox for my television. I haven't cut that cord. And the reason is because if there's trouble, I can call Cox at any hour of the day and night, and I have, and I can get a human being on the phone. Okay. and for me, it's worth it. All right. Now they may not always fix things. Now, to have them come and set you up on service is a whole nother experience, but at least their help desk is good. Okay, well, we've seen these dimensions, so we kind of get what we're trying to, we get an idea of the data, okay, and this is just the data table, and he walks you through this here in the text, okay. Now, let me say one other thing. There's another case in this text that deals with pregnancy duration, okay, and look, I understand what the case is about, and as I said before, he's a young guy and he likes to be cute and funny, so he has this famous case from probabilities, probably using probability theorems and outliers, and I'm not going to go any further. You don't have to read that. You're not required to read that. If it would be offensive to you, skip it, okay? Because just like there are a lot of good movies out there, okay, but they may have too much violence or too much cussing or nudity or whatever, that, you know, although it might be a really good movie, you might want to think about seeing it, okay? Or get cable and get on demand and watch it without your. My luck is, and I had this happen one time. My wife and I went to see a movie. It was kind of funny, wasn't it? But it had some of the usual stuff, and I just started to filter that out. But there was a couple from our church. They didn't see us, I don't think, but they got up and left when some of the cursing started. I'm not condoning cursing or anything like that. Okay, all I'm saying is, you've been forewarned, okay? And, you know, that's why they have dials on TVs. That's why you can, if you're in a movie, you can get up and leave, okay? Or don't go to the movie, or read the reviews of the movie and don't go see it if you think you'll be offended, okay? So, I always feel like I have to give that little rejoinder because of the case. Again, he's a young guy. He thinks he's being funny. Okay. Now, I was a little risque with you taking you to the case where we use the wines and all that. But our Lord drank wine, and it wasn't grape juice. It was wine, and just like Paul says, we're told that under grace, we can do what we want. But if we do something that harms our brother, okay, or we do something that impacts our relationship with the Lord, we need to lose it, okay? And I can tell you, I will say this: I love sparkling wine and I love champagne. To me, there is no other taste in the world that's so exquisite. But I don't buy it or drink it for a simple reason. It would be my luck that I'd be in the checkout aisle and somebody from my church would see me, and I might hurt my witness with them. And the other is my terror is I go somewhere, I have a glass of wine or whatever, and I drive home, I'm in a wreck. Okay, you never know. So for me, I just avoid it because I don't want to hurt someone else's growth or be offensive to them. And also, I'm just the kind of person, if it can go wrong or I'll get caught, it'll go wrong or I'll get caught. So I just avoid it. All right, enough about that. Now, we see the first is the basic data table, okay? We've got that going on. And then we start to move over to let's scroll down here and see how many cases we've got, all right? And we'll be able to tell that. I forgot how many cases. It's been a while since I looked at this. We have 400. We have 400 employees. Looks like, pardon me. It looks like 400 different IDs, and that's about right for a really intensive support center. Well, we've got 400 records. We know this. Okay, now we come down to the average tickets, and we get that. It's and that's reported. And now we scroll all the way down to the bottom here. We're going to see, okay, some summary data. We're going to see the mean and the standard deviation on all of these. Okay, let's talk about this for the, first of all, the mean, we know it's pretty easy to compute. Okay, the mean is what? Well, the mean is, you add everything up and divide it by the number of items. The standard deviation tells me, okay, the standard deviation indicates to me variability. All right. So we've got some summary data at the bottom of our table. So far, so good. All right. Now we're going to come down here and then we'll look at the customer rating. And again, we have those same summary data, so we understood it. Now we come to the tardies. So we've got our base data. And then we have aggregate data, that is the mean. And then we have a very simple measure of variability. And here it is, we use the standard deviation function. Okay, on B2 through B401. And so the mean, let's talk about that for a minute. The mean is 156, okay? And the standard deviation is 4. So one standard deviation above that's going to be 150. We're just talking about the average tickets per day. One standard deviation below the mean is going to be 152 tickets a day. So someone's kind of in what we would call in range. Then they're going to be processing somewhere between, pardon me, this would be 160, 152 and 160 tickets a day. Okay? And so using probability theorem, we know that the odds are about 68%. The odds are roughly, let's see, this is 34, this is 14. 34 and 214 is 20. About two-thirds of the time, okay, that someone's going to have is going to process that number, will have that average number of tickets. So far, so good. Just some simple data analysis. Now, he has to standardize these, okay? And let's look at this for just a moment. I'm going to click on the function arguments, and I think I have some notes in there for you as well talking about this. They're using the standardized function, okay, and the x here is the mean, okay, and then we see the we have, pardon me, x is the observation. I apologize. And the very first one is 151.8. Then we have the mean, i.e. the average. And then we have the standard deviation, okay? And we want to normalize that piece of data, okay? So we're cleaning them up. We're doing some data wrangling, okay? And we'll click OK. And there it is. And we do that for each person. So now just like when we were working with the when we were doing the cluster analysis and we added 1 to those probabilities so we could, we standardized them, okay? And here we're standardizing the data again to get that accomplished. Now comes our old friend, the distances, all right? And notice, okay, what we're doing is we have, and he's gonna talk about that with us in terms of distances. So open your book up, if you don't have it open already, all right, and you want to go over here to in that case of okay, here we are, we standardize them, and then I want to get you over to the correct figure, and we've got those. Show the distances. Here we go. I apologize. Figure 9.9 tells us about the employee distance, all right? And we take the distance of each employee in relation to other in terms of a ranking, okay? And he shows us we have those employees out there, okay? And we're going to do a rank here in just a minute, but we're going to compare each of the employees against each other. Obviously, you're going to see the diagonal. This is like a Voronoi diagram. You see, we always have, when they're compared versus themselves, it's a 0. All the way over here. Now, let's click on this. Let's click on the cell D3, and we're going to use the square root. That's simple enough, okay? And then we're going to sum, and then we're going to use the offset function, okay? Now the offset function, he gives you some explanation about that, and we used it back when we did the cluster analysis. Offset function, simple. I have a cell, okay? And on offset, I say, okay, how far am I going to go in terms of rows, and how deep will I go in terms of columns? And I'm going to use that offset before distances, okay? And I'll look at each employee versus the other. Okay, and we'll talk some more about this on Wednesday when I do the live screencast. Okay, so we're back using that. We're using that cluster analysis tool. Then we do the rankings in terms of how far people are from each other. And that one we'll take another look at as well. And then our K cluster means, remember we did those. And we're going to find out how many people are in the neighborhood, and we're going to see if they've got 5 neighbors. And then we're going to look at the reach distribution, okay? And then we'll look at the local outlier, and we'll build some local outlier factors. And we will do that, and we'll cover this in greater depth on Wednesday, okay? So I'm going to close this file off, and I'm not going to save any of the changes I made. And so I have Support Center, okay? Now I want to make sure it's a Microsoft worksheet, and you can use this one, or you can use the ones over there. But I'm going to, I can upload this, and if with the Outliers assignment, go ahead, do yourself a favor and upload it now, okay, and get that done. And then we'll look at the rest of it, how it's all constructed, and we'll follow through. Again, starting over there on chapter 9, which is page 335 in the Foreman text. Okay, folks, thank you much, and I'm going to stop the share and the recording and end the meeting.